So our next VNAV example here for instruction is what do we do with a DES point? So what I like to do for the setup is, and what I have right now in our secondary flight plan, is the Milton for arrival, doesn't matter the approach you throw in there, and the Keating transition, which is the typical move that we get coming from the west going east into LaGuardia. And then when we look at the route legs page and we scroll down, we notice that there's no TOD. I like to ask them, what threat do you see with this? If they don't notice it, I'll pull up the active flight plan on the other side of the screen and say, all right, compare and contrast these. Other than the missing speeds and altitudes, what's different? Hopefully they see TOD versus DES. And we can get into the weeds, and the Bombardier guys taught us in the beginning of this fleet that the DES point is a 3-degree path all the way back from the runway to the initial approach fix, back to the airport, and along the whole flight plan, just continuing on a 3-degree descent. But what I can tell you is, looking at this, the number is obviously garbage, right? And what are the threats here? It's not going to warn you as you approach it. If you select a lower altitude, it's not going to start down, and it's obviously way too high, right? Beauty is at 10,000 feet, and it tells us to start down from flight level 350, only 8.5 miles from Beauty. So what's the mitigation strategy for this? We obviously know we have a star with expect altitudes, or we have no arrival whatsoever, and we'll work through an example with that in a little bit. So it's got on the arrival mark at 180, or the lowest usable flight level, Biley at 13,000, and Beauty at 10,000. Now, this is about as complicated as I like to get with drawing lines. I like to show them how this box thinks when it's going to draw this path. And so you could draw the line from Beauty, and how does it come up with this second top of descent? I'll see how sharp they are. I'll say, hey, when we look at this, now we have a TOD. We got a TOD that's way back here. Notice before it was just shy of Beauty, but now it's actually after Keating. It's way out there, even before Milton. So that's obviously making a lot more sense, and we've mitigated the threat here of that DES point. But I look at this and I'll show them, all right, so the box actually starts at the bottom. It's looking at Beauty at 10,000, and it says, hey man, can I draw a 3-degree line going all the way up to flight level 350 and not blow through these other restrictions? Well, the answer is no, it can't do that. So then it says to itself, well, what is it less than 1? 1 is the lowest limit that it's going to be willing to do. And in this case, the answer to that is yes. And it goes, okay, well, what I'm going to do is I'm going to draw a 3-degree line and then have a level segment at 13,000. So it's got 3 degrees up to 13 level segment looking backwards. Next one, it does the same thing. Can I do 13 all the way up to 350? No. Well, what's the angle between 13 and 18? 2.04. 2.04 is greater than 1. Boom. Here you go. Then the next one is just going to be a 3.0 line all the way up to our cruise altitude of 35,000 feet. Now let me give you some teeth on the 1.0 thing. If I change the crossing restriction here to Beauty to 9,000 feet, the second TOD disappeared, and now the angle is 1.02. So VPath smoothing is gone. It's just going to keep coming down at that geometric path. And it's obviously inefficient, and you know ATC more than likely isn't going to give you a descent on that right away. And the big threat here that we can discuss is when the VPath goes full scale, it's just a full scale off of a 1.02 degree line, right? And we're going to see a message in our HSI, which is why we're so hard on our students to keep the HSI clear. And the message would say, no VPath, VPA. It's like I'm full scale down underneath this thing. I can't chase it. I'm not going to chase it. But what could you do to mitigate that? Vertical direct, and that makes a great discussion point. Well, what does vertical direct do? What does vertical direct do if you have between altitudes, right? And if we're above it, it's going to chase the top altitude. If you're in between, it's going to chase the bottom altitude when you use the vertical direct. And why that's not always the best idea to vertical direct things when you are descending on an arrival. It's not the wisest of moves. The next thing I like to do is delete the 9,000 out of here at Beauty, and then I'm going to change the altitude here at Biley, and I'm going to put it to 3,000 feet. And I like to show, okay, now I've got an amber altitude here. 4.5 is the angle coming down to that. That's the maximum angle that the airplane is going to allow to be done here with a pilot entered crossing restriction. And I can give you teeth on that, because if I change it to 4,000, it's still going to just be 4.5. I go to 6,000, it's going to be 4.5. And if I go to 7,000, if my math is right, this sucker's going to turn green and go to 4.47. Let's see if I know my stuff. Boom, 4.47 in green. I literally have no idea how to do that math. I have done this a million times and have just memorized how the box is going to behave. But we see the threat here. Do you really think this airplane in 23.2 miles is going to be able to come down at a 4.47 degree angle and slow to 250 knots below 10? No way. Remember, in this thing, it doesn't care about anything else other than VPath or VGP, and it sure will overspeed it. There was an event that happened in the beginning of this fleet when one of our crews was out doing an engine report, and they forgot that the auto throttles were off, and it was a buddy of mine that called me to tell me that he did it, and they oversped the aircraft because they forgot that the auto throttles were still off, and it caught a VPath and just ripped right through their speed. So the airplane doesn't care about anything other than VPath and VGP. That overspeed mode is not going to activate when you're descending in a path. So that's obviously a little bit of a threat here. I like to show as well that if I change the destination airport to Aspen, I know we don't go there right now, but Phil will tell you that network begs us to do it. And I'm going to load the RNAV Zulu runway 15 approach into Aspen off of the Red Table VOR. This is kind of wild. If we scroll down till we get to the approach, we're going to see that, look at the VPA on this approach. It's 6.22 degrees. That's steeper than what a steep approach is, but if anybody's ever been to Aspen before, the missed approach point isn't the runway. The missed approach point is way out there, about 1,500 feet AGL, and you got to maneuver around a mountain to get in and go into this runway. It's just diving you down to be able to visually maneuver in. But a procedure that's in the database will load with a greater than 4.5 degree angle. So for your advanced students, that's something kind of cool to point out. But now think about it. We've established multiple reasons now why we have an amber altitude, what we would do to correct them, the threat of a DES point, checking paper to glass, how the box works. We're doing a great job of a building block approach of how VNAV actually works in this airplane.